Hello and welcome to my talk, Becoming a Full Stack Developer, a Quest into the Unknown. As Alfonso said, I'm Gien, I'm from Belgium, and I have experience in creating software. In my spare time, I like to organize things so that software developers can learn. That's why I run the mentorship program for the F# Foundation. And I also help to organize Open F#, which is a conference in San Francisco, because it totally makes sense to organize a conference in San Francisco when you're living in Belgium. When I'm not doing any of that, you can find me on the couch with a book and a cup of coffee. If you want to know what I'm reading, check out my blog and my Goodreads, or you can follow me on Twitter. I'm here to make a confession today. I hate front-end development. And I know that's not the best thing that you can say when you're at FableConf, but it's true. To be more specific, I hate JavaScript. And the fact that I hate it is kind of sad, because a lot of software developers have a story where they discovered programming. You know, they read it in a book or discovered it online, and they fell in love with programming. I realized that when I was 13 years old, when you name a file index.html, you could make beautiful stuff appear on your screen. And it was only 4 years later in high school that I discovered that you could make that beautiful stuff also do things. And that was called a programming language. And they taught you that. There was just one problem. There was this programming language called JavaScript. And they sort of assumed that you understood it. And I didn't. And then I went to college, and they assumed you understood JavaScript, and I didn't. And I went into the work field, and they assumed that you understood JavaScript, and I didn't, and they called me stupid for it. So I was like, well, this front-end thing, it's not for me. I hate it. Being a full-stack developer is impossible. My heart is broken, even though it was my first love. I'm just going to focus on the back end, and that's what I'm going to do. But then something happened, and that is that I decided to become self-employed. And I thought, well, it would be really nice if I had more than just my back-end development skills to offer to people. So I looked up from my back-end development code, and I looked around, and I noticed that the scenery had changed a lot. They were offering sort of these dual packages now, like you had C# and TypeScript, Haskell and PureScript, OCaml and BuckleScript, and F# and Fable. And to me, it seemed like this shampoo and conditioner option that you got. Like, same smell, but different things. And I thought, maybe this full-stack development thing isn't so mythical anymore, and I should try to get back into it. And as an F# developer, I have more than just the Fable option. I know, spoiler alert, I picked Fable to study, but I also had BuckleScript, so I could go for Reason, or I could go for OCaml because of that. There are two reasons why I picked Fable. First of all, I had a possible contract with my first customer who was already using Fable. And second, I met Alfonso, and he was a really nice guy. And I did, for the past 6 months, I did a talk on how that is the worst reason ever to pick a technology, but it was, I didn't have that information yet at that point in time, but I figured, if I hate this and something goes wrong, he looks like a nice guy, and I can go and talk to him. So that is how I picked Fable. And that is why I'm here today. I'm going to talk a bit about my experience learning Fable as a backend developer. I'm going to talk a bit about how it changed my view on what beautiful code actually is all about. And I'm going to talk about what was missing. And I made a plan in order, to give you some structure. I'm going to talk about the tooling, so basically everything that is around Fable. I'm going to talk about Fable and the ecosystems. What is missing. I'm going to, wrap it up with a nice little bow. And if you have any questions, there's a moment at the end of the talk. I left some minutes available for you, and you can ask me the questions there. All right. So I have a backend experience, so I already know Packet and Fake. So what was new was Yarn and Webpack for me, but I didn't really need to care about that because, you have templates. Which proves to me how spoiled we are. Because Packet and Fake have this nice integration into Ionide, and you have these templates and they do everything for you, and we nag when it doesn't work straight away. But if you compare it to everything else that is out there, they don't have any of these things. But at the same time, it made it harder to learn front-end development again, because I was doing Yarn completely the wrong way. I was using it the same way I used Packet within Ionide, which was basically like changing the files and then trying to run something, but that didn't work. It was like, wow, this tool is utterly horrible to use. C front-end development hasn't changed that much yet. But I then actually started digging into it and started using it through the command line, and I'm getting pretty good at it right now. And the same with Webpack. I ignored that even more than Yarn because that was the only JavaScript that actually is still in the code base at this point. And you get it anyways when you install the template. But then I started using Fuma at the office, and I had to change our config files. And I sort of was like scratching my head, like I have no idea what this does. And at that point, it had been like 7 months that I used Fable. So templates hide a lot of knowledge. And it came at a moment that was very inconvenient for me to actually dig into everything it was doing. So I strongly suggest that just once you sort of like set it up from scratch so that you sort of have like a very clear image about what Fable is and what everything is around it. And then, Fable itself. I already had a lot because I knew F#. So I had my types, discriminated unions, list sequences, computation expressions. The thing is that not everybody on my team had the same background, so not everybody knew how to do all these things. And in our code base, you can clearly see, is this working? You're not seeing this, right? You can clearly see that it's all lowercase, so it has more a JavaScript influence when somebody else is creating the types. So I wrote my types the way I write them in F#, which is a curly bracket goes on a new line. Maxime is completely correct about that one. And the reason why I love it so much is because you declare your type card, and then you use your curly brackets to sort of frame what is a card right underneath it. And you use, 4 spaces to really make the difference. So if you move away from your file and you just look at the colors and the empty lines and the indentations, you need to understand what your code is about. And if I can reach that level, then I have written good code. That is how I try to do it. I don't always succeed. I always want to make it light. I want to smile when I open a file. So after every column and before every column, I add a white space, because it makes your code light and it makes you happy. I just had one problem with Fable, and that is I wasn't entirely sure how to read it. I knew my computation expressions. I knew that it was let bang, because I had a mentor who explained to me that, hey, this let exclamation point is sort of pronounced as let bang. But when it came to Fable, I didn't have that. And it made it harder to learn because I couldn't really read what was going on in my head. You know how when you read a book, you hear the words in your head, and I couldn't do that with Fable, and it made it a lot more difficult to learn. But again, we're really spoiled because some of these special operators have IntelliSense, and you can just check out what they do. So there was just one thing, and when it came to lists, I wrote them the way I wrote my lists in F#. And it made me very sad. Because even though I had a lot of space, so it should make me happy, it wasn't. And I looked at other people's code, and I came across this guy named Maxime, who wrote his code, and I looked at it and thought, well, that is ugly, I'm not doing that one. Which I told him, by the way. And I was like, I'm going to find my own way. It's going to be so much better than this. And then the second thing that was difficult to learn was the language influence that you feel. Like, this is called a toast in Todd, and I have no idea why. Like, this does not make sense in my head, and I Googled. And apparently, like, you can call this a snack bar or a toast, presumably because the notification looks like a toast popping out of a toaster. I honest to God think that that software developer never made toast, because the way I do it is that I take a fork and I jam it into the toaster to get my bread out. That's how it works. And the second one I found weird was a promise. So a promise in English is a declaration assuring that one will or will not do something. It's a vow. And in JavaScript, it's an object representing the eventual completion or failure of an asynchronous operation. And it just didn't match. You know, my English explanation didn't match what actually was happening in JavaScript. So I went looking for the origin, and I asked a couple of people, and the most common answer I got was that, you know, people break their promises all the time. And I thought, like, that is the most depressing thing I have ever heard. I'm not taking this for an answer. I'm going to find, you know, the happiest person that I know who has sort of this thought about philosophy of programming. So I went to Thomas Petricek, and I asked him the same question, like, where is this promise coming from? Because it doesn't match with my English. And knowing Thomas, he had a very elaborate answer. He referred to me to a paper that first used a promise. He also gave me a bunch of Wikipedia links. He told me that, you know, the way closure works with his future and his promise is completely different. And so basically the first reference to a promise that you can find is in this paper. And it says that because of the suspending cons, so cons is the function, it stands for constructs, and it creates your data structures. So because of the suspending cons, Z is initially bound only to a promise of this result. So basically it says, like, it's not here right now, it will be there in the future, and it doesn't talk about a failure path. So I was right, but like figuring out the origin, you know, keeps it better in my head to understand what it's doing. And just, you know, not to completely bash JavaScript, F# also has some weird things. Like, these are called banana clips. This does not look like a banana, but I think the name is like way cooler, so I would just say we will start using this now instead of active pattern. So then Elmish. Again, I have already a lot of knowledge. I have my discriminated unions and my pattern matching, which pretty much is what you need for it. And I also already knew the model view update from Elm, because I had seen a couple of talks in Elm. And that pattern it's a bit of a weird thing. Like Alfonso told in one of his talks that you have this instinct to not render the view completely, but that this is how you should do it. And I'm here to tell you that he's completely right. Because the company I work for right now created an adaptation called Elmish-ish to make it very easy. And that just made the whole learning process for me so much harder. Because whenever you bump into a problem, you're wondering, like, is this because we have an adapted version? Or is this because I'm not getting something about Elmish? And then you have to go and ask help. And you're sort of like, yeah, but we don't just use Elmish. And it just makes everything difficult. The documentation doesn't fit, the examples don't fit. And you don't really need it. And we came to realize that too, because we're looking into, you know, reverting the process of this adaptation. So please do not do this. But the good thing about Elmish is that you have awesome autocomplete and discovery. Like, we have a nice list here. You can even some have like a very elaborate explanation, and I love this. When I see this, like this has complete like why you should use it, when you should use it. It also has a link to the GitHub issue that it's solving. Like this is really, again, showing that we're pretty spoiled. There's just one thing, and that is that I don't like abbreviations in your code, specifically. Like program.makeProgram, like I know where the MK comes from, but I don't think it adds any value to just dropping the files here. And I think that beautiful code means that you should write the entire word. Of course, if it's an acronym, like hot module replacement, then you can use it. So then you have so the layer of React. So I knew HTML, and I knew lists, but like I'm not entirely sure that at this point in time that this is helping me. When you look at it, it has a B, which is a sequence of HTML props, which was very confusing, because as far as I knew, HTML tags had attributes. And then you have C, which is just another sequence of React elements. And this is how you then write it. So you have the HTML tag div with the HTML attribute name. And it felt like multiple influences were starting to become visible in this language. And if you go looking for it, it pretty much states that properties are to React components, what attributes are to HTML elements. So you sort of have this coalition here of both. And the second thing that was very difficult was I had used an on-click, and I expected it to work, and I wasn't sure whether it was my Elmish or not, so I asked for help. Basically, it doesn't quite work the same way you would expect it to work in JavaScript. And I went looking for the answer. So some things in React don't work the way they would. And then I figured, this is probably like the end of the line. Like, I loved it when Julian said that we're all using React and we like have no idea what it does. And I was like, oh yeah, hey, hi, this is me. I'm using this, but I have no idea what it does or how it works behind the screen. And I feel that if I want to get better at it, I have to sort of learn React, and I also eventually will have to learn JavaScript if I want to cross that. Don't know if you noticed at the first slide, but I am starting to adapt the way I write my divs. I started adding white space between the open and closing brackets. I don't put everything on a new line anymore, so it still had space, and I was already feeling a bit happier about how I was constructing it, but I just felt like it wasn't quite there yet. And then I came across Fuma. And things I already knew, well, I have nothing for you, because Fuma was something completely different. And I loved it, and because I didn't have to put a div into a div into a div anymore, with slapping some CSS on it, it was talking about the purpose it was going to fulfill on my screen. And Fuma often gets sold as this statically typed CSS, but I think it's so much more. It's a ubiquitous language between HTML and CSS, so that you don't really notice anymore that you're like using two components of the front end. And for me, that was like really great, because in my views, I could see, when I read my code, I could actually see what it was going to be on my screen instead of just a bunch of strings. It also had better IntelliSense than I was used to, because it talked about having options and having children. It showed you what eventually it would generate into. I was really happy about that. There was just one thing, and I thought that it was rather spacious, and I had to add a lot of redundant things. So I went looking into the code as to why. And so it turned out that it had a coalition with F# and with React. So the button is for React, and the box is a keyword in F#. And because of that, all the modules were marked require qualified access. But all of them, even when it wasn't needed. So I felt I was adding a lot of redundancy, but at the same time, I realized that your code looks very consistent because of that. And it would have been quite different if not all modules had been marked like that. And even though I didn't have quite compact code anymore, what I did gain was discoverability, because I could check what was inside the module column and how to use it without having to go to the documentation. Of course, it's not perfect. There are some linguistical conflicts that I have with it. One of the examples is you have is 1/4, and then you have is 3/4, but then you have to use is half. And that just doesn't make sense in my head. I feel like is 2/4 would have been the right thing here. Also, what doesn't make sense is that a grid is 12 columns, and I have is 1 until is 11, and then I have to say is full. Like, I really would have liked that 12 because it creates a certain consistency in my views that I don't have right now if I want a full column. But basically, so Filma not only made the way I viewed the code differently, it also finally gave me that edge to create like beautiful code again, like code that made me smile. Because I could move away from seeing this as lists and actually seeing this for what it did on my screen. So I came up with a couple of rules. So empty properties and children are on the same line. You add you sort of group the elements that belong together on your screen by leaving an empty line after them. So if you step away, you can see again like which groups belong together. And same as with my types, I used the square brackets to sort of frame what a button exactly is underneath it. And also what I do with my types, if I only have like 1 or 2 fields, I put them on the same line, and I do that here too. Which is, almost exactly like Maxime wrote his code in the first place. So you can see his code here, and it's basically the same. So he was right all along. I just, took the long road to that conclusion. So what is important, like when you go from C# to F#, you need to sort of forget stuff in order to write really beautiful code in F#, and I had the same feeling with Fable. Like, you need to let go of how you write certain things in F# to actually create meaning in your code in Fable. And what I'm doing right now is, like I said, it takes up a lot of space, and it's starting to run off my screen. So I started thinking, this had the benefit that I started thinking about sort of extracting certain components that belong together, and start thinking about grouping logic and views together and use them as child components in other views. So that's basically what I'm trying to learn right now on a daily basis, is like what's the, some sort of heuristics for creating components. So what I wish I had was clarity. Clarity on 3 levels. First, I have no idea whether or not I actually grouped any of these comments correctly, because I have not a clear view of where Fable ends and the ecosystem starts. Except for Fuma, which is clearly optional, you often hear like you don't have to use React, you don't have to use this. I just have no idea how you would do it. And I'm not sure that's even true at this point. So, a bit more clarity about Fable and the ecosystem. Secondly, a bit more clarity on what makes a good Fable application would be much appreciated. Although, when I learned this, the documentation and the demos and stuff was not as good as it is now. So the clarity is coming on that part, I think. And third, a clarity in language. Because right now, when you use Fable, you really feel all the influence that it has. You feel F#, you feel the HTML, the CSS, the React, and the JavaScript. And like I said, Fuma is a good attempt on combining that and creating a combined language. But I think that we can go a lot further in this for Fable and really create this Fable language that everybody can start using. Why? So I work for a company that does synthetic biology, and right now they have this DSL called genotype specification language, which is to do DNA design, which is based on F#. And in my company, because biology is something so complex to understand, we figure that sometimes it's just better to teach the biologists programming than to teach us biology. This is just not possible anymore. So our biologists, the strain engineers, actually create command line tools that they can use for themselves, and we then sort of separate all the functionality and put the things that we need to use for a web application into it. Although it is expert-friendly code, they don't use special operators, they don't use a lot of piping, they don't really care about immutability, which is fine. And the thing is also, sometimes they want to show us what it looks like, so they offer us HTML files. And HTML is really easy, and I feel undervalued, because if you change something in the file, you can immediately see it on the screen. Something which we don't have right now with Fable, because we're using Elmish-ish. So I hope that gets fixed. So I thought, maybe they could, start prototyping these things in Fable, and we could go from there. That would have been an awesome thing to do. But there are two problems that I have. And I think one of the reasons they don't use operators is because they're very hard to discover naturally when you're using the language. And I can't expect them to do, to put the same amount of effort into learning a programming language than I do. And second is that they have no idea how they even have to read them. So I feel there's a hole missing there for both software developers and domain experts. Because there's this thing called a register. Basically, a register is a subset of a language, like in English in this example, designed for a very specific purpose. Which is why that instead of sort of staring at the screen weirdly, I can tell you 6 multiplied by 6 equals 36. That's because they made a language called mathematical English, and we get all taught this language when we go to school. And I thought that it would be really cool if we had something like this for F# and therefore for Fable. So why? Well, first, because then I could cooperate better with my software developers, my colleagues. I could cooperate better with my domain experts, because we had this language to talk about. And why should you care about that? I don't know how things are in your country, but right now in Belgium, we have 4,000 jobs that are unable to be filled in when it comes to programming. So we really need to start thinking about redefining what a programmer actually is, and how we can collaborate with the users. And that would be awesome, and I think it would be very important for that to actually have a register. So about my broken heart I talked about in the beginning, it's healing because of Fable, I think. I'll never love front-end development, but the days I had to do it used to really, pardon my language, suck. And I didn't like it, and now I basically have to do front-end development every day, and it doesn't make it a bad day anymore. So it made it neutral. Fable made it neutral, and that's already something big for me. So is it possible to be a full-stack developer? Yes-ish, because we love it. I do feel that at some point I will need to learn React and JavaScript to become an expert, because if I don't, I'll get stuck with the level that I have right now, and I really want to continue growing in this. So are there any questions? No. Yes?
Can you explain a bit about this idea of the register you are envisioning for something like that, or Fable?
All right. You mean this?
Yes.
Yeah. So basically what this... I'm going to look for a nice piece of code. What that would mean is that you would... I don't have it. I already tried to do that with functions. Of course, I don't have any functions here. This is all just... basically, what you would do is you would sort of decide on a word that matches certain symbols. Like the x matches multiplied by. So you could say that if you have a function, like let temp ID equals, then you would sort of start saying like an open bracket is width, basically. So you could really read the code very fluently out loud, and people would know what to type when they're listening to you talk about your code. Does that answer your question? I can give you examples. I have them on my laptop. I just don't have a good example in my slides.
Okay, yeah, but so you want like a language that makes us spelling the code actually in a way that it's more easy and understandable to the people, and you're also linking this to the teaching of programming to non-programmers.
Yeah.
Yeah, I think because I was thinking about this idea of having the register or the way of doing. Thank you.
Yeah. All right. Thank you very much.